Beneath Antarctica's icy surface lies a hidden world that has recently captivated scientists and adventurers alike. Groundbreaking discoveries have revealed secrets buried beneath miles of ice, challenging long-held views of this remote continent. 30 years ago, Antarctica was often portrayed as a lifeless, frozen wasteland. However, we had the foresight to believe otherwise, and today, the evidence speaks for itself. Antarctica is far from a mere white block on the map. These revelations offer not only a window into Earth's distant past but also a glimpse into the possibility of life in one of the planet's most extreme environments. Ancient ice cores, for example, serve as windows into Earth's climatic history, providing some of the most detailed and continuous records of our planet's climate over the past 800,000 years. These cylindrical samples, extracted from ice sheets in regions like Antarctica and Greenland, have been pivotal in unraveling Earth's climatic past. Two significant projects in this field, the European Project for Ice Coring in Antarctica, EPICA, and the Vostok Drilling Project, have produced remarkable findings. EPICA has been conducted at two sites in East Antarctica, Dome C and Concordia Station, with the Dome C core reaching an astounding 800,000 years into the past. Meanwhile, the Vostok Project, based at Russia's Vostok Station, has provided ice core records dating back 420,000 years. Using special drills to quickly reach the bottom of these massive ice sheets, scientists work tirelessly around the clock to uncover these secrets. The structure of ice cores, with layers of snow and ice accumulated over millennia, serves as a historical record much like the rings of a tree. Scientists analyze these layers for trapped gas bubbles, isotopic compositions, and particulate matter, which reveal past atmospheric conditions, including greenhouse gas concentrations, temperature fluctuations, and even volcanic activity. The findings have been nothing short of groundbreaking. Ice cores have uncovered natural cycles of glacial and interglacial periods driven by shifts in Earth's orbit and axial tilt, known as Milankovitch cycles. They also show that current greenhouse gas levels are unprecedented in the last 800,000 years. Additionally, ice cores have revealed rapid climate shifts, such as the Younger Dryas event around 12,000 years ago, and layers of volcanic ash embedded within the ice provide a timeline of significant eruptions, helping scientists correlate global climate events. Discovered in 1996 beneath Russia's Vostok Station, Lake Vostok is another marvel of our planet's extreme environments, further highlighting Antarctica's hidden potential. The discoveries beneath the ice challenge our understanding of life and climate on Earth, providing a fascinating glimpse into the past and a hint at what may lie ahead. This subglacial lake, one of the largest in the world, lies beneath approximately 4 kilometers of ice, making it one of the most isolated and extreme environments on Earth. Known as Lake Vostok, it is the fifth largest lake on the planet, covering about 12,500 square kilometers, roughly the size of Lake Ontario in North America, with an estimated volume of 5,400 cubic kilometers. The lake reaches depths of 500 to 900 meters and was formed 15 to 25 million years ago due to tectonic activity and glacial coverage. Having been sealed under ice for millions of years, Lake Vostok presents a unique, isolated environment maintained by geothermal heat and pressure from the ice above, which prevents it from freezing completely. The scientific significance of Lake Vostok is immense. Ice cores drilled near the lake have provided a continuous climate record for the past 400,000 years, offering invaluable insights into Earth's climatic history. The lake's extreme isolation and unique conditions could potentially harbor life forms adapted to its dark, high-pressure, nutrient-limited environment, sparking astrobiological interest. These conditions mirror those that might exist on icy moons such as Europa and Enceladus, making the study of Lake Vostok a stepping stone for future space exploration. The lake could reveal new biogeochemical processes and microbial life forms, enhancing our understanding of life's adaptability in extreme conditions. The characteristics of Lake Vostok invite intriguing comparisons to Jupiter's moon Europa, both being covered by thick layers of ice with liquid water hidden below. This similarity makes Lake Vostok an important terrestrial analog, helping scientists develop technologies and methodologies that could one day be used to explore these distant icy worlds. However, exploring Lake Vostok presents significant challenges. The thick ice cover requires advanced, clean drilling technologies to prevent contamination of the pristine environment. In 2012, Russia's Antarctic program successfully penetrated the lake using a specialized thermal drill and drilling fluid, ensuring the protection of the lake's ecosystem. Strict sterilization protocols are critical to avoid introducing foreign microbes or pollutants into this isolated ecosystem. Preliminary analyses of water samples from the lake have hinted at microbial life, though further studies are necessary to confirm these findings. In addition to the lake, vast subglacial river systems, believed to rival the Amazon in scale, have also been hypothesized. Future missions aim to explore the sediments of Lake Vostok, which may contain ancient microorganisms and provide clues about past climate conditions. Evidence of Antarctica's warmer, greener past can also be seen in fossilized forests discovered in the Transantarctic Mountains. These fossils, dating back millions of years, include remnants of ancient trees, plants, and even entire ecosystems, offering compelling proof that Antarctica once hosted a much warmer climate and lush landscapes. The Transantarctic Mountains, which span across the continent, are home to many of these remarkable discoveries, further expanding our understanding of Earth's dynamic environmental history. Notable sites in Antarctica include Mount Achernar, where fossils of Glossopteris, an extinct seed fern, and other plant species have been found, and the Beardmore Glacier, where fossilized wood and leaves provide a glimpse into the once thriving forests of the region. Many of these fossil forests date back to the Permian period, between 299 and 252 million years ago, when Antarctica was part of the supercontinent Gondwana. Further fossil evidence from the Cretaceous period, 145 to 66 million years ago, suggests that forests persisted as the continent gradually shifted toward its current polar position. The discovery of temperate and even subtropical plant fossils indicates that Antarctica once experienced a much warmer and more humid climate. These fossils, which include various plant species such as ferns, conifers, and seed-bearing plants like Glossopteris, point to a rich and biodiverse ecosystem. Analysis of these remains offers valuable insights into past CO2 levels, precipitation patterns, and ecosystem structures. Comparisons can be drawn between Antarctica's fossilized forests and other ancient forests found around the world, such as the Petrified Forest in Arizona, USA. Both sites offer a window into Earth's distant past, highlighting how drastically different the planet's climate and geography were millions of years ago. However, Antarctica's fossil forests are particularly remarkable given their current location in one of the coldest, most inhospitable regions on Earth. In 2022, another landmark discovery was made when the wreck of Ernest Shackleton's ship, Endurance, was found in the Weddell Sea, solving a century-old mystery surrounding one of the most iconic maritime losses in Antarctic exploration history. The ship, astonishingly well preserved, offers a tangible connection to Shackleton's legendary 1914 to 1917 Imperial Trans-Antarctic expedition. The wreck was discovered about 3,000 meters below the surface, roughly 4 miles south of the position originally recorded by the ship's captain, Frank Worsley. The cold, dark, low-oxygen environment of the deep Weddell Sea has kept the ship in remarkable condition, inhibiting the growth of wood-eating organisms. The name Endurance was still clearly visible on the ship's stern, confirming its identity. Shackleton's Endurance expedition aimed to achieve the first land crossing of Antarctica. However, the ship became trapped in the Weddell Sea's pack ice and was eventually crushed and sunk. Shackleton and his crew's struggle for survival and ultimate rescue remains one of the most extraordinary stories of endurance and leadership in exploration history. The wreck's discovery was made possible by advanced underwater technology, including autonomous underwater vehicles equipped with high-resolution sonar and cameras. The mission was led by the Falklands Maritime Heritage Trust, involving a team of marine archaeologists, historians, and technicians. The wreck of Endurance serves as a powerful symbol of the heroic age of Antarctic exploration and the indomitable spirit of explorers like Shackleton. Its preservation offers a rare opportunity to study early 20th century shipbuilding techniques and materials. This discovery has reignited interest in Shackleton's expedition and the lessons of leadership, perseverance, and teamwork that it embodies. The finding of Endurance can be compared to the 1985 discovery of the RMS Titanic, as both wrecks represent significant historical and technological milestones of their era. Found using cutting-edge underwater exploration technology, each has captivated the public's imagination while offering invaluable insights into maritime history and the human stories behind these legendary vessels.